12.16. If Bohr's quantization postulate angular momentum equal to nh upon 2 pi is a basic law of nature, it should be equally valid for the case of planetary motion also. Why then do we never speak of quantization of orbits of planets around the sun? Now see here, if we consider the second postulate, angular momentum, that is nh upon 2 pi, then in that particular case, n value that will be tremendous large one. In one example, we already calculated it. Okay. Now, if n value is large one, then energy calculations will give you the energies in the successive energy levels, or we can say states or orbits, that will be with very, 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 very small differences. It implies that the angular momenta that we can treat as continuous one, but not discrete one. Okay, and therefore here we can't consider it for planetary motions. And one important thing that you have to keep in your mind here, planetary motions, or we can say planet, that is the observable universe. So in observable universe, the laws of classical mechanics are applicable, and these laws of quantum mechanics are applicable at microscopic level. This can't be combined. Clear? Next, the last one, 12.17. Obtain the first Bohr's radius and the ground state energy of a muonic hydrogen atom. It implies an atom in which a negatively charged muon, it is represented by the symbol mu minus, of mass about 207 times mass of electron orbits around a proton. So mass of muon, that is equal to 207 times mass of electron. Now in the same orbit, we know this thing, R proportional to 1 upon m. So R mu R upon Re, that is me upon m mu. So R mu, that is Re into me upon 207 times me. Then here you will get the radius of the orbit in which muon is revolving. Then energy in the given orbit, that proportional to mass. So we can write energy muon upon energy electron, that is mass muon upon mass electron. So E mu, that is E electron into 207 times me upon me. So we will get minus 13.6 for the ground state of electron into 207. This much is your answer. Clear?